Hello, this video is for IXL activity 8.V.7. This activity is titled Evaluate Absolute Value Expressions. And the 3-character code for this activity is 2 Yankee Alpha. So we're continuing on with the concept of absolute values. And one thing that we've learned from previous activities is that an absolute value of any number is always going to be positive. And here we're being asked to evaluate. So that means evaluate means to actually come up with the final answer. You're wanting to get an answer. You want to work it all the way down to a final answer. So in evaluating, we also know that we have to substitute in whatever the value is for whatever the variable is that they give us. So our first example here is like -2 minus the absolute value of j. Well, j is a variable. It is a symbol that represents a value that can change. And in this case, that value is supposed to be 8. So we're going to rewrite and substitute it in. Then we'll take the absolute value of the 8 that we're substituting in, and then we'll go ahead and work it down to a final answer. And that's what it means to evaluate, right? So let's start off. I'll rewrite -2 minus the absolute value of, and then I'm going to plug in j. So I just rewrite it. I'm not really doing any math yet. I'm just rewriting the equation and then substituting in the value of the variable. So in this case, j is supposed to be 8. So I can now go ahead and work that out. So -2 minus the absolute value of 8 is going to be +8. And now I kind of like to, this negative minus a positive, I like to think of it this way. I can take the first number, -2, I can change the subtraction to addition, but then I have to take the opposite of the next number. And we had an activity on opposites, so we know that -8, the opposite of 8 is -8. And now I'm adding 2 negative numbers together. See why it seems to work a little bit, it's a little more friendly that way, you might say. Because I'm adding 2 negative numbers together, I know it's going to get more negative, and 8 plus 2 is 10. So -10 is my final answer. On the next one, I have the absolute value of -7. Remember, we're just going to rewrite it, and then we're going to substitute in whatever the variable is. In this case, the variable is f, and its value is 6. So now, before I can take the absolute value, I actually have to add these together. So -7 plus 6, well, if I'm on a number line and I'm down at -7 and I'm going to add 6, it'll almost get me to 0, but not quite, right? It's going to get me at -1 because I go 6 units. So I'm going to have -1, bring down the absolute value signs. Now I can go ahead and evaluate the absolute value of -1, and it's +1. So my answer is +1. On the next one, we're going to evaluate the expression for g equals -2. So let's do a rewrite here. Let's bring our negative value. Instead of g, we're going to put in -2 and then +7. Let's go ahead and take the absolute value of -2, which is +2. Bring down our +7. And I strongly encourage you to, if you can do this in your head, that's fine. If it starts to get too difficult in your head, then grab a piece of paper and jot it down like you see me doing. And 2 plus 7 is 9. So our final answer is 9. On this next one, we're going to have some, this means -2 times, you'll see that there is no operation sign here. So we know that this is multiplication there. So I know that I need to take -2 and multiply it times the absolute value of y. In this case, y is -9. And then, after I do the multiplication, then I can do the addition. All about order operation, right? So we have -2. Going to take the absolute value of -9. Oh, that almost looks like a parenthesis, didn't it? Let's make that a straight line. Big difference in math. Plus 6. So now I have -2 times, and now I'm going to use parentheses because this is going to be multiplication here. And I'm just going to use parentheses to hold the absolute value of -9, which is +9. And then I have to add 6. And then after that, I'm going to rewrite this over here. So I got a little more room. -2 times 9 plus 6. So I now need to do this multiplication first. Negative times a positive is a negative. 9 times 2 is 18. Notice how I say 9 times 2 as I point at the 2, then the 9. Same difference because multiplication is commutative. Order doesn't matter. So, and then negative 18 plus 6. So if I'm picturing on a number line, I'm at negative 18. I'm adding 6, so I'm going back this way. 0's down here someplace, but I don't have enough to get me all the way to 0, so the answer is going to still be negative. And just how far will it get me? Well, if I go 6 units, that's going to take me to negative 12. The difference between negative 18 and negative 12 is 6. So it's going to be, I wrote 6. Give me a second. Got mixed up in my words there, right? That is not supposed to be negative 6. We're adding 6 to it, and we're landing at negative 12. There we go. All right, and on this next one here, we're going to evaluate the expression for c equals negative 2. And we're going to rewrite 8 plus 3 times the absolute value of negative 2. Let's go ahead and bring down the 8 plus and the 3. And then we're going to use a parenthesis to hold the value, the absolute value of negative 2, which is going to be positive 2. Now we have 8 plus, my brain is just not here today. It's early morning whenever I'm doing this. So 8 plus 3 times 2 is 6, and 8 plus 6 is 14. So my answer is going to be 14. On this next one here, it says evaluate the expression for m equals negative 5. So I have 3 times the absolute value of m minus 11. So I'm going to rewrite this 3, bring down my absolute value symbols, substitute in the value of negative 5, and let's bring down the minus 11. Next, I need to do the absolute value of negative 5. So I'm going to write 3, use parentheses to hold the absolute value of negative 5, which is positive 5, and then I'm going to subtract 11. Now 3 times 5 is 15. 15 minus 11, that would give us 4. All right, got a few more here. So we're going to evaluate the expression. Oh, now they're getting tricky. Now we have 2 variables, and we're going to have to substitute in 2 values. So for z is negative 19 minus, and then the absolute value of whatever y is, and y is 3. So I'm going to take negative 19 minus the absolute value of 3 is 3. Now this is negative plus or negative minus a positive. I'm going to rewrite this as negative 19, change the sign, and then take the opposite of the number that follows. Well, the opposite of 3 is negative 3. And now I have a negative plus a negative, so it's going to get even more negative, and I know to add these values. 19 plus 3 is 22. So my solution is negative 22. On this next one, evaluate the expression for h is going to be equal to 9, and j is going to be equal to 51. So let's go ahead and substitute in the h, absolute value of 9, minus 51. And now the absolute value of 9 is 9. We're going to subtract from it 51. And this is one of those times that I like to do that change the sign thing. I'm going to move this over here. And 9 minus 51. And I'm going to rewrite this as 9, change the subtraction to addition, and then take the opposite of the next number. So the opposite of 51 is negative 51. And I now know that if I picture this on a number line, I'm starting at 9, and I'm going to add a negative 51. So I'm going back this way. It's like subtracting 51, right? What we had in the beginning. And say 0's right here. So I know it's going to definitely take me back past 0 to the negative numbers someplace down here. The question is just where's it going to land down here? Well, I'm going to use 9 of that to get to 0, and then whatever's left over, I'm going to go the rest of the way. So I actually need to know the difference between 51 and 9. So you could think of this as 51 minus 9. right? And I could do the long subtraction there, but I kind of like to think of it as this. What if I did 51 minus 10? Well, that's real easy. That's, what, 41, right? But I was only supposed to take away 9, so I need to add 1 back to that and get 42. So it's going to be, remember, negative 42. So my solution is negative 42. And these are my last two examples here. So on the first one, I have 9, and we do have two variables again, times the absolute value of whatever g is. Let's look. G is negative 8. And subtract from that the value of h, which is negative 16. Now I want to demonstrate, notice how my minus sign is like right at the middle level of the numbers. But my subtraction sign, I've raised it up higher so that I don't accidentally mistake a negative sign as a subtraction sign. So kind of a good strategy to use there. Then I'm going to go ahead and do 9 times the absolute value of negative 8, which is positive 8. And then in this step here, I'm going to go ahead and change the sign from subtraction to addition. Notice the change in the sign there. But now I'm going to take the opposite of the number that follows that sign. Well, the opposite of negative 16 is positive 16. Next step is to do 9 times 8, which is 72. The thing about my 9s is that I always know that whenever I multiply some number by 9, that the result is going to be a number that if you added the digits are the numbers in the number, the single numbers in the number. And so if I did 7 plus 2, I would get 9. And that always happens. Anytime you multiply a number by 9, you're always going to get a result that if you add the digits together, they're going to have a sum. They're going to have a total of 9. So I know that I'm good to go on my multiplication there, just kind of a mental check. And so I got 72 plus 16 equals, well, I can do this mentally, but I'll write it out. I like to think of this as 72 plus 10 plus 6, because 16 is 10 plus 6, right? So I could think in my head 72 plus 10 is going to be 82, plus 6 is going to be, what, 88? So my final solution is going to be 88. And then finally, I have one here. Here's an interesting one. Both of the variables are inside of the absolute value symbols. So let's just rewrite it, bring our absolute values. I'm going to open them up a little bit to have room to put everything in. Whatever W is, 67. And then I'm going to add to that negative 69. All right. And then I need to take the absolute value of that. So first I need to do the, I have to have the sum of 67 and negative 69. Sum means to add, right? So if I think of a number line here, and I'm starting at 67, and I'm going to add a negative number, that means that I'm actually going back, right? Adding a negative number is like subtracting a positive, and it's going to take me back 69 places. Well, I'm going to use 67 of those to get back to 0. 67 of those units were used to get to 0. So what's left over? Well, just a few more, and that's going to give me negative 2. So 67 plus a negative 69. And don't forget the absolute value. Everything's still inside the absolute value symbol. It's going to give me negative 2. Now I can evaluate the absolute value of negative 2. Well, absolute values are always positive, so this just becomes a positive 2. So my solution is positive 2. All right, so those are all of my examples for IXL 8.V.7, evaluate absolute value expressions. Good luck with your activity.